limit of what? Functions of real variables. Limit of functions of real variables. Now this is what your lesson 3. Lesson 3, that's chapter 3 of what? Math 120. Now the first thing that should come to your mind is what is limit of a function, or what is limit of functions of what? Real variables. Take this down. Limit of function of a particular point. Limit of function of a particular point describes the behavior of that function at that particular what? Point. Limit of a function at a particular point describes what? The behavior of that function at a particular what? Point. What do I mean? Let's say we have a limit of the function x squared plus x divided by x as x what? As x tends to what? 0. That is how you what? You express it. Limit as x tends to 0 of the function x squared plus x divided by what? X. How do you solve this? Now turn over to page 12. You'll see this question. Page 12 of your workbook. You'll see this question. How do you solve it? Now for you to solve the limit of a particular function, basically we have two steps or what? Two methods in solving what? Limit of a function. The first one is called the transformation method. The transformation method. While the second one is what we call the L'Hopital rule. L'Hopital rule. Now there are other methods or there are other approach in solving what? Limit of a function. But these are the two basic what? Approach or two basic methods of solving what? Limit of a function. Now let's use the first one, which is what? The transformation method in solving this our first question there. Now, for you to solve this first question, what do? You simply bring this down. The limit as x tends to what? 0 of the function what? X squared plus what? X divided by what? X. Now, what is the scope we use in solving what? This limit of this function with this method. Now, when you are using transformation method, what should simply come to your mind is factorization. That is what? The transformation method approach. Factorization. So if you can be able to factorize some certain questions given to you or some certain equations given to you, then you are good to go. Now what do I mean? When solving what? The limit of a function with this method, the first method, transformation method, is look at your numerator and look at your denominator. What your concern is you make your numerator look same as your denominator such that one of your numerator and one of your what? Denominator can cancel out or they are what? Equal. What do I mean? I mean factorize your numerator such that you have a variable or a value that is the same with your what? Denominator. Now let's do this. Let's break this down by factorizing our what? Our numerator. If you factorize our numerator, you simply have what? X bracket what? X plus 1 divided by x. The limit as x tends to 0. If you expand what you have here as your numerator, you will simply arrive at this, which is what? X squared plus x. Now look at your numerator and look at your denominator. What can we see that are equal? You can see x here and you can see x here. So the x here and the x here, they are cancelling out. What are you left with? You are left with the limit of x tending to 0 to be what? X plus 1. X tends to 0. What do we mean? Anywhere we see x, we are representing it with 0. Now if you do that, you simply have 0 plus 1. And 0 plus 1 is equal to what? 1. Now let's use the next method, which is the L'Hopital rule, to check if we have the same answer as what? As 1. Now for the next one, which is the L'Hopital rule. L'Hopital rule is simply telling you to differentiate. So if you can differentiate properly, your elementary differentiation, if you can do that very well, you are good to go with what? Limit of a function using what? Your L'Hopital rule. But what makes students fail very well in the exam is most at times your lecturer gives you choose a particular what? Method to solve your what? Limit of a function in the class. Now if you are not using that method, then you are what? You are getting it wrong because there isn't what is called the mapping scheme. So be very careful when solving questions, except it is what? It is an objective question. Then you can choose to use which of them to get your answer very fast. But if it's an essay question, if it's a theory, use the method you are taught in class so that you won't fail it. Let's use the El Hospital rule method to solve questions. Now, for this El Hospital rule method, we have what? Limit of x tends towards 0, x squared plus what? X divided by x. What do? You are differentiating your numerator and you are differentiating your what? Your denominator with respect to your what? Your given variable. So we are differentiating with respect to our what? Our x, because our x is the what? The given variable in your what? Your question. So if you differentiate that, you simply have the differential of what? Your numerator, which is x squared plus x divided by the differential of what? X. So this is limit as x tends to what? 0. Now what do? You differentiate your numerator. What will you have? You simply have what? 2x plus 1 divided by 1. Limit as x tends to what? 0. Divide this. What will you simply have? You simply have that this will be written as what? Limit of x tending to 0 will be the same thing as what? 2x plus 1. What is the next thing? X tends to 0. Anywhere we see x, substitute what? 0 inside. So we simply have what? 2 bracket 0 plus what? 1. 2 times 0 is what? 0. 0 plus 1 is what? 1. So you can see that using your transformation method or your El Hospital rule method, you will still arrive at the same answer. So use the one that is what? Convenient to you when it's an objective question. Look at page 12 of your manual. What's the next one? The next one says what? The limit of a function x tending to 0 of the function x squared minus 2x divided by x. This is the next one. How do you tackle this? Let's use the transformation method to solve this before we use the what? El Hospital rule method. Using the transformation method, I simply told you that when you are using the transformation method, look at your numerator, factorize your numerator such that you have a variable that is equal with your what? Your denominator. Now doing that, you simply have the limit of x tending to 0. Factorize your numerator, what do you have? You have x bracket what? X minus 2 divided by what? X. Now if you expand your numerator, you simply arrive at what you have here. So what do? Since you have a variable here equal to a variable here, they simply what? Cancels out. What will you left with? You are left with limit of x tending to 0 of what? X minus 2. What's the next thing? Anywhere you see x, substitute what? 0. So if you do that, you simply have 0 minus 2, which is equal to what? Minus what? 2. So this is your answer using your what? Your transformation method. Now let's use the El Hospital rule method to what? To solve this what? Equation. Using the El Hospital rule method, El Hospital rule. And I told you when you are using this El Hospital rule, then you should be good with what? Differentiation. Now, if you have this as what? The limit of x tending to what? 0 of the function x squared minus 2x divided by what? X. What do? You differentiate your numerator with respect to x and you differentiate your denominator with respect to what? X. Now, if you do that, you simply have the limit of x tending to 0, the differential of our numerator, which is x squared minus 2x divided by the differential of our denominator, which is what? X. Now if you do that, what will you simply arrive at? You are differentiating this and you are differentiating this. Remember, when we talk about differentiation, what is the rule we are using? We are using what? Nx, n minus 1. This is what? Differentiation. Now if we use this approach in tackling this, what will you have? It's simply what? You are differentiating this first one, which is your numerator, to be what? 2x minus, you differentiate 2x, what will you have? A constant divided by, differentiate a variable, what will you have? A constant, which is what? 1. So if you do that, you have limit of x tending to 0 to be what? This divided by 1 here. You simply arrive at what? The limit of x tending to 0 to be what? 2x minus 2. What's the next thing? Anywhere you see what? X, substitute what? 0. So you simply arrive at 2 bracket 0 minus 2. 2 bracket 0 is what? 0. 0 minus 2 is what? Minus 2. So you see that you are simply getting the same answer as your what? Your transformation method. So if you use your L'Hopital rule, you still get the same answer with your what? Your transformation method. Now, take the next one in your manual. The limit of x tending to 1 of the function x squared plus what? X minus 2 divided by x minus 1. Let's use what? The transformation method in solving this question. Now, using the transformation method, what is the first thing? Look at your numerator. Factorize your what? Your numerator. Because you are having what? A quadratic equation. So if you solve this quadratic equation, you simply arrive at what? The limit of x tending to what? 1 will be what? The function of what? If you expand this, if you solve this quadratic equation, you simply have x minus 1 bracket x plus 2 divided by what? X minus 1. Look at what you have here. Look at what you have here. You simply have what? One of your numerator equal to what? Your denominator. So what do? You simply what? Cancel them out. So you are left with what? The limit of x tending to what? 1 of the function x plus 2. Now what is the next thing? Anywhere you see x, what are you substituting it with? You are substituting what? 1 to it. So you simply have what? 1 plus 2 is equal to what? 3. Now, if you use the L'Hopital rule method in solving this equation, you will still arrive at what? 3. Now let's look at the next example there. Now looking at the page 12, the last one which we'll be talking about there is what? The limit of x tends to what? Minus 2 s of the function what? X cubed plus what? 8 divided by x plus 2. Now let's use the L'Hopital rule method in solving this because we've used the transformation method here. So let's use the L'Hopital rule to solve this. Now using the L'Hopital rule, what do? You differentiate this and you differentiate this. So you simply have the limit of x tending to what? Minus 2, the differential of what? X cubed plus 8 divided by the differential of what? X plus 2. Now, if you differentiate this, what will you arrive at? If you differentiate x cubed plus 8, you simply have what? 3x squared. Differentiate the constant, you have what? 0 divided by, if you differentiate x plus 2, what will you arrive at? You simply arrive at what? 1. Because you are differentiating only this. If you differentiate this, you simply have what? 0. So the limit of x tending to what? Minus 2 of the function what? 3x squared divided by 1. So if you do this, you simply arrive at the limit of x tending to what? Minus 2 of the function what? 3x squared. What is the next thing? Anywhere you see x, what are you substituting? What are you putting in? Minus 2. So if you do that, you simply have what? This to be what? 3 bracket what? X is what? Minus 2. Minus 2 raised to the power of 2. It's simply telling you that you have 3 all what? Minus 2 times minus 2. So if you do this, you simply have what? 3 bracket what? 4. Now 3 times 4 is what? 12. So if you have this as 12, use your what? Your transformation method by simply what? Factorizing your numerator, this polynomial here. So if you factorize this polynomial, you will simply have a variable or a value that will be the same as your denominator, such that your denominator and your numerator will cancel out, and you'll be left with what? The other part of the what? The factorization. Now after that, what do? You what? You simply substitute your what? Your x tends to any number given to you. That is how you use your what?